Welcome to this explainer. Today, we're doing a really fascinating refresher on the sheer anatomy of the machines driving our world. I want you to think of your device not just as some basic utility, but almost as a biological entity, you know? It's got a physical body carrying out the heavy lifting and an invisible mind orchestrating all the logic. For those of us living and breathing tech, it's incredibly rewarding to take a step back and examine the structural foundations of personal computing. We're going to break down this complex anatomy into a crisp, insightful framework that will completely reshape how you perceive the silicon and code sitting on your desk right now.
Okay, let's dive into this. Here's our roadmap for today. 1. Basic anatomy. 2. Hardware, the physical body. 3. Important hardware organs. 4. Software, the invisible mind. And finally, 5. Types of software explained. Starting right off with Section 1. Basic anatomy, the core components. Because every single digital device rests on one fundamental truth. At its absolute core, a computer exists entirely through this beautiful symbiotic relationship between hardware and software. That is literally the grand equation of computer science. Hardware without software, well, it's just lifeless metal and plastic. And software without hardware is just a floating concept, instructions with absolutely no physical reality to execute them. They are entirely interdependent. It's so much like the human brain and human consciousness. You really can't have one without the other.
Which brings us to our second section, hardware, the physical body. Let's focus entirely on the physical realm for a moment.
Hardware is the tangible reality of technology. It's the physical components you can literally see and touch. And honestly, it's wild to think that the physical hardware inside a standard, modern, smart LED bulb packs more processing power and memory than the Apollo 11 guidance computer that literally took humanity to the moon. Whether we're talking about a massive server rack or just a tiny little microchip, hardware is the physical muscle that executes the logic.
And this brilliantly illustrates how that physical body is neatly organized. Think of it just like human biology. You have senses for input, like your keyboard, mouse, and scanner. You have vocal cords and expressions for output, your monitor, printer, and speakers. You have a brain for processing, the CPU, motherboard, and RAM. And of course, you have a hippocampus for permanent storage, your hard disk, SSD, or pen drive, acting as the ultimate filing cabinet for all your data.
Section 3. Important hardware organs. Zooming in from those macro categories, let's look at the vital organs that actually dictate your daily user experience. First up is RAM, Random Access Memory. Think of RAM as your active workspace, like the top of your physical desk. It operates at blinding speeds, often measured in nanoseconds, which is exactly why your CPU relies on it to actively juggle browser tabs, apps, and live documents. It's incredibly fast, but there's a catch. It's volatile. The split second the power cuts out, that workspace wipes itself completely clean.
Because of how heavily the processor relies on that active workspace, there's a golden rule in computing. More RAM equals a smoother machine. If your device is bottlenecking or lagging when you're switching between heavy applications, it is rarely the processor failing you. It's almost always the RAM running out of space, forcing the whole system to slow down and inefficiently swap data around. Now, if RAM is the active workspace right there on your desk, your hard disk or SSD is the filing cabinet down in the basement. This is your permanent, non-volatile storage. It's the physical home where your operating system, your photos, videos, and complex game files actually reside, safely preserved even when the power is entirely shut off.
So, the crucial point here is the choice between solid-state and mechanical architecture. SSDs utilize flash memory with zero moving mechanical parts. What does that mean for you? Blazing fast data retrieval. We're talking booting up operating systems in mere seconds. Traditional hard disks, on the other hand, rely on physical, spinning magnetic platters. Now, they do offer massive amounts of storage at a fraction of the cost, but that physical mechanical limitation makes them significantly slower. Modern tech overwhelmingly favors the instant, snappy feel of an SSD, for sure.
Tying all of this physical hardware together is the motherboard. And it's way more than just a skeleton. It is the ultimate digital superhighway. Every single piece of hardware we just talked about, the CPU, the RAM, the SSD, it all plugs directly into this central nervous system. It facilitates billions of electrical signals passing between the processor and the rest of the machine every single second, ensuring absolute, perfect, synchronous communication.
So, we've got the physical body. We have the brain, the ultra-fast memory, the data vault, and the superhighway connecting them all together. But on its own, it's just inert silicon and metal, right? It needs instructions. It needs a mind. Which leads us to the ultimate question. What exactly is software? Section 4. Software, the invisible mind. This is where we pivot away from silicon and enter the invisible realm of pure logic, code, and execution.
Software provides the strict, logical instructions that breathe actual life into the hardware. Think about the profound reality of this for a second. Software is pure digital intelligence. It has absolutely zero physical mass. You interact with it constantly, watching it operate beautifully on high-resolution displays all day long, but you can never reach out and touch it. It is pure thought dictating physical action.
And finally, Section 5, Types of Software Explained, let's move to and see how this builds. Because just like the body relies on different physical organs, this digital intelligence comes in a few distinct flavors.
We can generally distill this intelligence into two fundamental camps. System software is your foundational manager. It's waking up the components, allocating the RAM we talked about, and keeping the hardware running smoothly behind the scenes. Application software, on the other hand, consists of the direct tools built specifically for you. The relationship is beautifully simple. System software talks to the hardware, and application software talks to you.
Now, what's really interesting here is that massive, globally dominating names like Windows, Android, and Linux are essentially just background managers. They are system software. They form the unseen foundational layer. Without an operating system managing those complex hardware resources in the background, executing any specific task would be mathematically impossible for the average user.
And built perfectly on top of that foundation is application software. Chrome, Word, WhatsApp, Photoshop. These aren't managing memory or CPU cycles. They are highly specialized tools engineered directly to interface with human intention. You open one of these apps to achieve one specific goal, relying entirely on that system software below to make your intention a physical reality.
As we wrap up this explainer, I want to leave you with this thought. The very next time you open a messaging app to text a friend, pause for a second and ask yourself, are you interacting with the hardware, the software, or the perfect harmony of both? Your fingers touch the physical glass, but you're navigating a weightless, coded interface. That code tells the RAM to load your data in nanoseconds, while the motherboard routes signals directly to your Wi-Fi antenna. It's a brilliant, invisible dance between body and mind happening millions of times a second, right in the palm of your hand. Keep exploring, and I'll see you in the next explainer.